everyone, you're here again with the Winning Gist. This is Elena, and on this occasion, we're gonna talk about high traffic WooCommerce. We're gonna cover everything about hosting, performance, and how the right hosting solution can make all the difference for you. For this special video, we're joined by Christos from Pressidium.
Hi, I'm Christos. Nice to be here.
Thank you for joining us. Maybe you want to start by telling our audience a little bit about Pressidium.
Hi, I'm Christos Paloukis, performance engineer at Pressidium. At Pressidium, we do managed WordPress hosting, and we try to do it at its finest. We're a boutique service, so we're not a big company. We have about 34 employees at the time, and we pride ourselves on having true high available environments, which is really important for WooCommerce websites or e-learning websites too, anything with an LMS. Well, naturally, we pride ourselves on our support. I'd like to consider it no BS support, because someone is always going to be there. You're always going to have a human to talk to that can help you with your problem, whatever problem you might have. And sometimes we go a little bit overboard too, by helping a little more than what's required of a hosting provider, I'd say.
I think that's something that every website owner likes to hear.
Yeah, sometimes we get ourselves in trouble, I guess, with too much support. Although we do have the capacity to, spend enough time with each customer to actually get their solution up and running the way they want.
So we at Winning just totally understand that. That's exactly why we created our WooCommerce maintenance plans, because we know that these websites sometimes need a little bit more support, especially right now, for example, with the sales seasons that are approaching. So we created these plans to help support the sites as they scale and as they encounter day-to-day problems. Today, we're going to talk about exactly this case, high traffic WooCommerce, maybe the sales season, maybe your business just gets tons of concurrent users. So to get started, I wanted to talk about a common scenario, the sudden traffic spike, which is going to become an issue pretty soon with Black Friday, Cyber Monday, Christmas shopping. So imagine you have a flash sale, a product launch, thousands of users are getting to your site. How does your team handle resource allocation in these situations?
Anyway, the festive season does provide some challenges, like the ones you described, particularly for anything Black Friday or Cyber Monday or Cyber Week oriented. To properly pin down, potential bottlenecks, we'd have to preemptively conduct capacity planning consultation with a client. So we would sit down with the client and see what kind of traffic they get in general, how many visits they expect per, a certain amount of time, per minute, per hour. During a flash sale, knowing that it's going to happen beforehand, so like open communication with whatever client would be ideal. And then we can actually put that to the test by conducting load testing as part of the capacity planning consultations. Load testing is where we would, again, look at the traffic map of the website, see what users typically do, and try to simulate that by applying virtual users and scaling those virtual users on that site. And in the meantime, recording the response times for every different process, or maybe the add to cart button. Gathering all this data afterwards and writing up a nice report really helps with capacity planning, so that we know what exactly, or just about what we need to do to get the client through with those spikes in traffic that they could expect.
And once you do know what you expect, once you know what you're dealing with, what are some of the strategies that you could apply to help prepare your client sites?
All right, so preemptively, we can conduct capacity planning consultation with the client. That would include load testing or stress testing. And to do that, we would use our own architecture that we have for stress testing to try to identify what kind of traffic the client is expecting. Like, a user going to the homepage of the site, or maybe going directly to some other landing page, then finding a product that's hot for Black Friday, adding that to the cart, paying for that product, and then taking that whole routine, let's call it a routine, and putting it into a test plan. And what happens next is virtual users are created, and simultaneous virtual users, so concurrency, we're testing concurrency here, that run that routine, that test plan, as if they were regular users. So we're basically trying to stimulate a high traffic scenario on the infrastructure hosting the actual client site. Doing this, you can get some conclusive results as to where some potential like obvious bottlenecks might be on the website. You'll definitely know which pages perform better than others. While the routine is being run, response times are being calculated for all of the requests. So we know we get a really good image of how the site will perform with 100 concurrent users, for instance, or like a burst of users, because maybe you have a TV show, or I'm sorry, a TV commercial, where after the commercial, everyone starts hitting your site. So part of one of the most important parts of that would be having open communication with the clients, so we could know when they expect bursts too, and then we can guide them along the way, saying that, oh, maybe we can add some extra instances, some extra nodes. We'll talk more about the architecture later for the hosting that we use at Pressidium, but maybe we can add more caching power. Maybe we can add more backend database nodes, because people will be making purchases, so there's going to be a high number of writes on the database. That's why we need open communication with clients as far as their sales go, or when they think they're going to receive more traffic. Reactively, we can always do on-demand vertical scaling. We don't do horizontal scaling, or well, we do horizontal scaling, but we do not do horizontal auto scaling. Because we're not a private cloud, we're not a cloud provider or a container-based hosting provider. We only use bare metal and VMs. So that's like hard or virtualized machines. So they're quite similar to actual bare metal. It's all for performance. It's all performance oriented. Plus, it's a bit trivial to actually have horizontal auto scaling applied to WordPress, as WordPress is a stateful application. Meaning that it relies on persistent data, file system database, and user sessions. So when replicas are being made, or if multiple replicas are being used for writing, you might have inconsistencies between the data. And we don't want that. So it's not safe. It's not safe. You can't have a auto scaling on a fully stateful application like WordPress. A high available setup is a must in this situation, not so much just for like availability. So it's not just so that we know that if one node goes down, another node is there to take over. It's also to spread the load, raising performance. Yeah. Right, so high availability is important there. The other thing we can do is traffic shaping. So we do have load balanced arrays where the users' requests are spread across multiple nodes for hosting a website or any of the web functions of the website. With traffic shaping, we can identify, label, and route specific traffic to a central point, and constant monitoring, so we know what's going on the website during these high traffic periods.
Yes, of course. Monitoring is key. We also do that from maintenance level, constant website monitoring, and performance reporting. Yeah. So you also briefly mentioned caching. So let's talk a little bit about caching for WooCommerce sites, because I know that can be a little bit complicated, because WooCommerce does have this mix between dynamic and static content. So just for anyone out there in our viewers that isn't entirely clear about caching is basically saving a copy of your website that can be quickly retrieved, so that the whole website doesn't have to be processed every time it's loaded, and this just makes it a little bit faster. But the thing with WooCommerce is that not all parts of your website will always be the same. There's dynamic content such as your account, your cart, your checkout page, and of course dynamic blocks, like those little sections that you see with the recently viewed products that are changing every time and for each user. So how would you handle caching to ensure that there's good loading, but at the same time all of these parts of the site are not affected?
Yes, caching can get really complicated. Full page caching is what you described. It's the simpler kind of caching, where the entire web page is served from a cache, making it much quicker than having the request need to go to the backend, needing WordPress to work, needing database requests to happen, and then having the page served. Instead of all that happening, the saved page is served right away. Object caching using Redis, and using Redis as a session store, and also using Redis to handle WP transient API requests is probably going to help your site, especially if you have multiple similar database requests, for instance, going from the front end to the back end. When I say front end, I do mean the caching layer, or where the traffic first comes into. We'll look at that more when we look at the architecture that we use at Pressidium. Generally speaking, for our caching solution at Pressidium, we use a 2-layer varnish solution. There's 2 layers because the first layer is hosted in memory, so it's like hyper fast, and that's going to handle most of your basic full page cached requests, like the homepage, for instance, or the contact page. And the second layer of caching is of lower priority, and it's stored on and it's hosted on SSDs. Personalized caching is possible using Then there's the segregation of cacheable and non-cacheable components per page, like caching static headers and footers of a page, or like caching parts of a page and serving those parts of a page from the cache while serving the rest of the page from the backend. So the request actually goes from WordPress to the database, comes back, and everything. That's for situations like logged in users, like being able to cache parts of a page to logged in users. Typically speaking, when it comes to logged in users, uncached content is served, but using some techniques like edge side includes on the varnish layers that I described before can make it possible for us to be able to serve parts of a page cached while keeping the other parts of a page personalized. So it'll actually say, "Hi, Ellen," when you log into your site.
Oh, that's great. But how do you manage cache and validation for example, inventory that is frequently updated?
At Presidium, we do automatic cache invalidation based on user or administrator options. That could be actually pushing a button. That could be editing a product, for example, or creating a new post. In situations like that, there's an automatic trigger that does invalidate the cache. Also, cache, we have a TTL, of course, on everything that is cached. So after a certain amount of time, the page has to be requested again so it can be put in cache. So the most recent version of the page will be served to the person trying to access it.
Okay, you also mentioned the load balancing earlier. Could you walk us through how you configure load balancing for these high traffic WooCommerce sites?
Cool. Again, that has to do with our architecture that we will go into, I promise. But in a nutshell, it starts with the edge layer, like the whole network layer, where the traffic first comes in. So you type presidium.com and your request comes into us from the edge layer. The edge layer then sees the request and makes a decision of where to send that request. There are multiple nodes on the edge layer that receive these requests, and then those requests are then routed to the second layer we can call the application layer, where we distribute the load across multiple web servers. After that, if the page requires some sort of interaction between the web server and the database, it gets sent off to the database layer, which again is a multiple node layer, just like the other two are. So after the request leaves the web server, it goes to the database, and then it comes back from the database to the web server and makes its way back to you. This will make a lot more sense when we do look at some visuals and talk about Presidium's architecture. But for now, I think I'll leave it at that.
Yeah, and it's kind of helpful for me at least to picture it, like 3 lines of defense. This one comes in one scenario, this one in another, and this one in another.
Yeah, you could think about it like that. You could think about it like 3 layers with multiple lines of defense per layer.
Well, yeah,
that's a good
that would be more precise. And how does this setup vary for different client needs?
The default for us is using a 5-node setup, where we would have 2 nodes with the web application firewall. That's where all the requests go in through, and the caching engines, the 2-layer varnish caching engine that I mentioned before, hosted. After that, there would be 2 servers there. After that, we have the web servers and the database servers. The database servers can be part of a whole different layer. Like we could have the 1, 2, 3, 4, 5, 6, 7 node setup. In the 7-node setup, we have literal different physical servers for the databases. Otherwise, if the site doesn't require that much horsepower, the database and the web server can be consolidated onto the same nodes. By default, our databases are an active arrays. That means reads and writes are done on both or more of the database nodes. That's something that can be turned off. There could be a master slave setup that might work better for some e-commerce websites or LearnDash or general LMS websites.
Okay. So that can be personalized, but there's like a general setup that works in most cases.
Well, yes. And again, it does have to do with, like, now that we're talking about high traffic, if it's an e-commerce website, I can tell you like right away during traffic spikes, we're going to need more nodes in the web server layer or in the database layer, and not so much on the first two layer, the caching engine.
Okay. And moving on to another important topic regarding performance, I want to talk a little bit about CDNs, which CDNs are great for optimizing, but they do get tricky when it comes again to dynamic content like the cards, the checkout pages. So how do you integrate CDNs without affecting any of these?
Well, just like with caching, it's very similar to caching, actually. We have to identify what should and shouldn't be served from a CDN. So static assets like images, fonts, and videos can be routed through a CDN, whereas dynamic content, like account-related page assets, or the cart and the checkout pages, they would probably have some content that's going to be excluded from being served by the CDN.
Okay, so in all of these cases, it's all about getting strategic, avoiding collateral damage, and just trying to optimize as many elements as possible.
So yeah, exactly. Things like URL-based rules and bypassing API requests like WP Ajax help maintain that balance.
Okay, but what about real-time backups? How do you keep WooCommerce databases and files backed up without really impacting performance?
So for all our clusters that do have high availability available, because we do have options that don't offer high availability, there's an active backup, I guess you could say, all the time, because there's replication happening between the arrays of servers in each different tier, as we talked about before. Aside from that, there's automated backups that could be run up to hourly, instant backups that could be run just by pressing a button, and we do offer offsite backups as well for dumps of your data that's held offsite. As far as files go and like file management, file backups, it's the same thing, because we use in the high available arrays, we use a shared file system. So again, there's replication happening on the web server from one server to the other. And everything I mentioned before, as far as the instant backups and the automated backups and the offsite backups, is also available for files.
Talking about files, which is another important factor that we also work with our clients, with implementing solutions for optimizing their images or minifying their media. From a hosting provider standpoint, how do you handle file management for media, for WooCommerce sites with high traffic or that have super large catalogs with tons of products?
Well, that's easy. We do apply basic techniques like compression, and CDNs may play their part here too, unless, of course, the personalized caching solution with multiple regional nodes is part of the solution. In that case, the CDN might not play a very beneficial role in serving things faster, files specifically. And under that, in the actual infrastructure layers, we use fast SSDs they're a must. We use fast SSDs for all of the file storage options. And I'm going to talk about the high availability arrays again, because offloading and separating the traffic across multiple servers is going to help keep things running smoothly.
So now that we would have all of this running correctly and that we're prepped, how would we monitor performance and how can we make sure that things are continued to working well over time? Do you have any tools that you recommend for identifying bottlenecks in WooCommerce sites?
Well, yeah, just real quick. Installing New Relic, which we have streamlined too. at Presidium. Installing New Relic will give you insane insight on granular insight too about your website and your website performance. Another thing you could do is see what's going on the back end of your website using something like the Query Monitor plugin. It's super insightful. Then there's always what I mentioned before, like load testing. So that's all called protocol-based testing. Anything that has to do with simulating virtual users that are accessing your website and interacting with it as if they were actual users. Online services out there like Octoperf and K6 Cloud can take care of load testing or stress testing, protocol-based testing. You can also implement your own custom solution like we did at Presidium for our internal load testing architecture using technologies like JMeter and K6. As a hosting provider, a huge part of our job is monitoring like all our systems and services very closely. For that, we use a Nagios Prometheus and Grafana stack, but it's out of the scope for the actual site owners and developers. That's for our DevOps engineers to be super, super, super reactive with anything that might go south.
And once you have this data, you have this monitoring, let's talk about planning for the future. When a WooCommerce site anticipates this traffic growth, how do you as a hosting provider ensure that their infrastructure will be scaling efficiently?
Yeah, okay, so you can't really plan for everything, but when someone does come to us from the beginning, we will go through the process that I mentioned before, the capacity planning consultation with the stress testing. Optimizing the actual website itself might be super beneficial too, because if the website runs really well, really quickly, really snappy, and doesn't require a high amount of resources, then we won't have to apply as many resources to get the result we're looking for. So when we anticipate traffic growth, we start with capacity planning, and we need to identify the site's potential like needs in the future. What's good about all of that is what I keep mentioning over and over, the whole modular multi-tier design that our architecture has.
Maybe we can take a look at it now so we can go over its structure.
Yeah, let me do that. Let me pull up a visual for us, because everything does just keep going back to the architecture. This is you, the user, as illustrated here. When a request comes from you to a site hosted at Presidium, it's going to cross the first layer here that says network firewall, and where the web application firewall are hosted. This really helps in things like DDoS protection happening on our end, so on our infrastructure, and not just like the network infrastructure before our infrastructure, or maybe if we use a specific upstream provider or their network. It all has to do with like us. We're responsible for it and we handle it. Lots of security things happen at the WAF layer. After that, traffic is routed to one of the multiple load balancers that will be in your array if you have a high availability plan. Here's a visualization of the load balancers. In this particular model, we're looking at 3 different load balancers. The request comes in. If it passes the web application firewall and the network firewalls, and everything's okay, it moves on to the load balancing layers. The load balancing layers take the request, shoot it over to one of the multiple caching engines that, again, are the servers that are responsible for caching using that 2-layer varnish approach that I mentioned before. If the page is not something that's cacheable, or if the page is missing from the cache, like it's the first time someone's going to that page after cache invalidation has been done, then the request will be shot over to the app layer, where the web server resides and where all the files for the site files reside. Site files can also be hosted off-site. Again, there are other solutions that we provide where it's kind of like a CDN kind of option. But anyway, files are hosted at the app level. If the request in question needs database interaction, then it gets shut off to one of the database servers hosting the same database that's being replicated over multiple servers. Again, with active-active topology by default, but also with a active-passive, like a master-slave setup, where there's one database responsible for all the writes and all the rest are used for reads. And then there's content replication happening among all those servers. This is the foolproof architecture that we use at Pressidium. Now, there's lots of like reasoning and logic as to how requests are handled. What I mentioned before, for instance, like traffic shaping, where we would identify particular requests and set them to particular nodes, that could all be customized at a very granular level. But by default, it just uses some basic logic.
What is this little heartbeat that we see right there?
The heartbeat, it's literally the servers talking to each other very often, being like, "Hey, buddy, are you there?" And he's like, "Yeah, I'm here. I'm still here." Although, because if something does happen to one of the servers, like load balancer 2, for example, according to this illustration, the other load balancers need to pick up all the traffic that might have gone to load balancer 2. Then they have to remove that server from the pool in general, so it's not being used and requests aren't being lost. And
So it's like a little light signal.
yeah, exactly. And then our DevOps engineers would get an alert. There's processes like automated processes that try to get it back running. And if not, there's intervention from a DevOps engineer, which happens within 5 to 10 minutes, because those are like critical errors. And we always have someone or multiple people there waiting
to get that set.
Yeah.
So thank you very much for walking us through this. I also want to talk about something different, that it's third-party applications. So WooCommerce sites do have a lot of integrations, especially they do shippings and payment gateways. So this involves a lot of API calls. So what's your strategy for managing the server load for these API calls?
That's a complex topic, and that we're still working on a comprehensive solution for API call management, like API calls being made from the web server engine the application engine towards maybe a payment gateway. So it's a tricky one. It's a tricky question to answer. Though we don't do it yet, the process will include identifying the requests and using the pooling techniques. So maybe 1,000 requests per second per minute are going off to Stripe, but then you could see that there aren't good response times at a certain point. With pooling, we'd be able to put like a bit of a pause if we needed to on some of the requests. So think about like 5-10 requests trying to move through a water bottle kind of thing. Yeah. If they get stuck, it's a bottleneck. That's why it's called a bottleneck. And then if we do a bit of pooling, then we can tell 2 out of the 5 requests to lay a little back and have the traffic flow fluidly.
Okay, that helps me picture it a lot better. So lastly, for WooCommerce sites handling thousands of simultaneous transactions at a time, what server configurations do you recommend for database performance?
Cool. When it comes to databases, we are, for the most part, limited to MySQL with WordPress. So one of the first things that we have to look at when optimizing databases or just setting up databases is the storage engine that's being used by the database. InnoDB is the industry standard. MyISOM used to be, which is kind of trivial too, because there are circumstances where MyISOM is better. It's like better, it's not better, but the higher performance coming from MyISOM than InnoDB, but InnoDB is much more reliable and does provide features that MyISOM does not, that are required. That's why the industry standard is InnoDB. Proper database indexing is something that's always overlooked. Whenever we get, so if we get something like an alert about a slow query on one of the clients' websites, which do come in quite often, actually, we have the ability to go into the database, look at the query, try to analyze the query, and we usually end up seeing that indexing wasn't done properly on the database table. Indexing is something that really helps with lookups and lookup speed. So sometimes we have to add some custom indexes to tables. Super important and often overlooked, proper database indexing. Then there's some more like nitty-gritty geeky settings, buffer pool size settings that are used for storing data in memory over than on disk. That's something that should be configured. Well, best practices say should be 70 to 80% of the available RAM in the database layer. But that's also something that could be different per case. Again, WordPress websites among themselves are very different. Connection management, like what we talked about before with the polling. What else can you do? Again, replication really helps here because the whole load distribution, so high available setups. Then there's like custom per case solutions, uh, things like partitioning tables, which can get really messy. That's when you would take a large table, try to break it into multiple small tables, and then have your queries use the property adjacent server. I'm sorry, the adjacent table to get the result of the query. Load balancing can also be applied at the database layer for like between between the app layer and the database layer using something like proxy SQL. Then there are some per case like custom solutions that definitely have to do with the site in question because again, all WordPress sites are very different among themselves. There's table partitioning, which can get a little messy, load balancing, read-write splitting, manual configuration of query-based load balancing, which is something like traffic shaping that I mentioned before, but specific to the database layer. Query caching, which is something that could be done by Redis, and connection polling, like what we described before with avoiding bottlenecks by pooling connections. Proxy SQL can do. We implement most of these solutions using Proxy SQL at Pressidium. Proxy SQL is a champ for communication between the web servers and the database servers. Again, per case though.
Okay, so I think all of this information that you've given us will already answer a lot of the questions that were in some of our users' minds about hosting and what they can do to prepare their e-commerce sites for high traffic. But of course, there might be some questions left. So if you have any questions about hosting that you want us to address with Presidium, make sure you drop those in the comments below, and we'll be happy to answer them or maybe revisit them in another video. I just want to take a moment also to thank you. Thank you, Christos, for being here, for helping us out, for sharing all of this with our audience.
It was a pleasure. I really hope to do this again.
Yeah, happy to have you here on the channel. So I also want to take the moment to mention that any one of you that is having trouble with site performance or that you're getting ready for high traffic season, make sure to check out our maintenance plans. If you have any maintenance, optimization, or security questions, make sure to reach out to us. So thank you very much for being here, and until the next one.